Hi, welcome to our video presentation of QUICKSURFACE 2025. In this video, we'll go through our new features and show how to make reverse engineering faster, easier, and more efficient. To demonstrate our features, we'll go and make several reverse engineering projects. So let's begin. The first thing that we did was to improve the speed of importing larger STL files. With the new version, you can open STL files up to 3 times faster than the previous version of QUICKSURFACE. Starting a reverse engineering project has 3 major fundamental steps that every project must begin with: data size, data quality, and alignment. As you can see, even if we can handle this object in our software, sometimes the algorithms may struggle to process a big amount of data. And the reason for this is that it is not necessary to be so big. The new QUICKSURFACE 2025 offers the user a guided assistant, which is called Prepare Scan. Prepare Scan button is located into the main toolbar before everything else. It provides a step-by-step options for the user to set up his object. As I said, we need to analyze the size of the mesh. The software initially reduces automatically the mesh down to 50% and gives you some statistics how many points are within your working tolerance. You can get this message on top of the screen. In this current example, you can see that even if we reduce the size by 50%, 99.98% of the points will still be within 30 microns. What this means is that it will reduce the size without losing any accuracy. It's up to the user to accept this or keep working with the large files. Furthermore, you can analyze and see the deviation from the underlying mesh. If you're happy with this, you can just accept, or if you don't want to, you can just skip this step. I will just accept because this is better for me to work. The next major step is the mesh quality. The meshes coming from scan data may have a lot of floating individual submeshes, like in this case we have 69. Even it looks like a single mesh, there are a lot of small and unnecessary parts that may need to be cleaned up. And I can just go to individual meshes, pick the main mesh in this case, and leave it only this one, because this is what I need. Now I have only one mesh. As you can see, this turns to green. I can press to the next step, and the software asks me if there is any kind of symmetry. Although this object probably is symmetric, I'm not going to use my symmetry plane here because I'll use a different strategy for alignment. I can just skip this step. The software prompts me to align my object now. How we can align with the QUICKSURFACE in a traditional way is just by extracting the primitives. I can just pick this area. Holding the control key, I need to take this one and we'll fit a cylinder. As you know, we have this analyzer tool. We can take a look and see the quality of my fit result. This looks pretty good. I will just create this cylinder. The next primitive I need is this bottom plane. I can just click and extract it. Now, because the auto constraint is on, it automatically will make this plane perfectly perpendicular. For more detail about the constraining primitives while extracting, you can refer to our tutorials. I will just create this plane, and for the alignment, I probably will use this area to be my plane. I can play with the slider so I can get more information. In QUICKSURFACE 2025, we allow the option for the extracted plane to be perpendicular to other planes as well. you can see the difference by selecting this option. I will just create my third primitive. As I'm ready now, I can move to the next step, which is the alignment. Now, in a traditional way, I need to define my coordinate system. I can pick the cylinder as my major first constraint, that I want the z-axis to be through the middle. We'll pick second plane, which will define where my origin will be. And the third step would be to pick the third primitive that will define my direction. In this case, it's y direction. I'm happy with this. I can press apply, and then I can finish this prepare scan assistant. What we did here, we prepared our object and we are ready to start our reverse engineering. Let's begin reconstructing our object. We already have the cylinder. What I need to do is just to snap this to the top surface. I can just pick the cylinder, pick up the handle and hold the control key so it can snap to the mesh, and I can do the same on the bottom side just by dragging here. The cylinder is ready, and now we need to have this cutting. What we introduce in QUICKSURFACE 2025 is the command which is called unroll. The unroll command is located into the scan data menu, where you can access it. To be able to unroll the mesh, you need a cylinder. Cylinder will define how this mesh will be unrolled. I can pick this. What you can see on the screen is interactive, showing the coordinate system, which means how this mesh will be unrolled and where it will go after it has been flattened. This is where the global coordinate system will be. I can play with this and drag this plane to adjust if needed, or I can play this numerically here. I'll just leave it 0 for now. I can press preview, and I can see my unrolled mesh, how it will look like. If I'm happy, I can press OK. What the software did, it created another mesh which exists and it's unrolled, that you can work on, but also keeps the original data. It also created an entity which is called roll frame that will be used later for the rolling back the information. I'm hiding the cylinder and I get focus on this shape now. What I need to do is reconstruct this shape in a traditional way using a 2D sketch. Dragging. I'm trying to create a cross section just below the fillet, so I can define a nice and smooth lofting after that, and press create. I'm using the normal methods to extract this profile just by using the extract primitives. I can brush some lines here over, and this one here we also need a line. I need to extract this line here. This. What we have in the new version is the ability to be able to make collinear, which means that this one and this one needs to be on the same level. I create collinear constraint, and the same probably I need to do for these lines here. Make it collinear. You can see this is a horizontal, so this automatically will be horizontal. Let's intersect them, and for the purposes of the lofting I need to round all the edges, so I just create a small fillet here. The cut kernel requires a smooth shapes when it creates the loft command later, so make sure that everything is rounded. I will do the same here. I created my first sketch. I can just press OK. Enable the mesh, not this one, just the flattened. And we'll do the same at the lower level. I need two profiles to be able to create a loft surface in 3D. And I extract as close as possible to the fillet below. It looks okay for me, and I will just create my new sketch. I can use project sketches if this is perfectly perpendicular, but they are not. So that's why we need to recreate this. Again, I'll just use the same approach. We'll just brush over, extract, go to the same here. Let me hide the sketch one so you don't get mistaken. Here we can leave it as it is, and now I need to, oops, Control Z, I need to go back and accept this, and we'll intersect. Sorry, this doesn't need to be intersected, so I just leave it like this. Intersect this one. I forgot to extract this line. With the Control Shift I managed. Now, as I said, for the lofting we need to have round edges. This is really important, so that's why even small we need to add some fillets here. We'll come back here and create these shapes. Now I'm happy with these shapes, press OK. The next step of the whole process is what we call the rollback command. We can put the original data. Let me just save this on the disk for further use, and I'm going to select my sketch one, right click and select a roll 2D sketch. This will take the roll frame, use it, and it will convert this 2D sketch into a proper 3D sketch in space, which goes exactly what it needs to be. We'll do the same on a sketch 2. Roll 2D sketch, so I have the two nice, very well defined 3D sketches. For now I don't need these two sketches, and I need to focus and improve the 3D sketches on my mesh. I'll just go and edit. As I said, we need to have rounding here, so perhaps I can just delete these shapes, and we need to recreate them in a slightly different way. For example, this is here. I can probably just create another line on the mesh, and we'll create a blend curve. We need to have a tangency and similar number of surfaces so it can work. This is okay, and I go back to edit this one. In this case I need to join these two just by selecting the two with the Control key and right click and join the curves. Now these curves are joined. As you can see, we managed to create on this side. I'm going to see what's going on the other side of these sketches. Double click. I can just merge these together, which is here. Join these curves. Accept. Again, the same approach needs to be applied on the other side. Double click to edit, improve these slightly here. I know it might be easier for you just to connect these two, but this will fail later the creation. So what I'm going to do is just create another line here. This line will match this one, and we'll create two blend curves here. You can adjust if you need to. As you can see, we use the unroll command very accurately and precisely to recreate our shape that I needed. So this is what we have right now. It looks a little bit mess. Let me save it, but it should work perfectly fine because I'm going to use the loft command, pick this profile and the other one, and it will create the surface for me, nice and smooth. I need to extend this, probably with 3mm is enough, so it can go inside. You can see here that this might be really a problem later if we don't define the cylinder correctly, so I need to go back and repair this shape. Here I can just delete and redefine my shape in a more accurate way. Just pick this shape here and delete it. Please keep in mind that you need to keep the consistency. That's by creating these, create the blend curves here, and press OK. Let's recreate again the loft shape. like this one and this one. So I click on this one and click on this, so it can create it and create it. So this is way better and it will do the job, and I accept. Now I need to show these 3D sketches again, and we'll create another loft just by picking on this shape and this shape. This might look simple, but it's quite a complex shape which I'm trying to do, and I created it here. Let's move to the next step that we need to do. Let me just save this, and it's to extract the inner cylinder. I'm going to extract primitives. Let me hide the surfaces for now. And here is the time to introduce our next feature, which is the segmentation. It's located into extract primitives, and you can just click the first button that will make a segment for you. The segments are different parts of the mesh that are colorized differently, and they are based on the curvature. You have the control again with the slider to play and see how it has been defined. This is actually to define the radius and the sensitivity of the curvature, so you can pick more accurately. And this is good enough for me. I can just pick on this, and then I can create my cylinder. So this is my extracted cylinder. I can always analyze and see. You see the result here is because of it's been machined in this way. It's automatically constrained and made it coincident with the z-axis, and this is pretty good what I need. Let me hide, and so you can see my extracted cylinder. Let's go back and get the first cylinder, and then I have the other two loft shapes. What I need to do is make sure that they intersect properly, so I need probably to pick this cylinder and make it taller. You need to investigate here the intersection between the surfaces so you can get a nice and good result. It doesn't happen here, so you need to make it larger. And I think we are ready to go. The next step would be our trim command. Just select everything and go to trim. The software initializes, it says it's a multiple surfaces, but I can start just creating what I need. I remove my excess materials here. It still says multiple surfaces, so I probably need to hide these and see what's going inside. And remove. You can see it now, it says a solid body. So this is what actually I need to achieve. Once I'm happy, I can press OK. So this was one of the features that we introduced in our package, which is called row on row. The project is not done yet. What we have is the ability to make this transparent at any point, so you can see how it overlaps with the scan data. And now I need to create a cutout and define my opening inside. How we can do this in traditional way? I can just pick this cylinder and say I'm going to create a 2D sketch. I'm not going to bother about now this shape where it cuts. I just need this profile. I can just create this sketch. What we have here in our new QUICKSURFACE is the ability for the use of what is called a clipping plane. Sometimes it gives you a nice cut of the scan data so you can understand what's going on inside and how you can just work on this in a more efficient way. I don't need the solid body, but probably I can see the inside of the mesh just by using this clipping functionality, which is quite useful in many cases. Perhaps now is the time to introduce what we call a Sketch Assist. Sketch Assist is an automatic extraction of the data that will interpolate and create, in many cases, the sketch for you without any interaction. As you can see here, we easily, just with a single button, it extracted our shape. You can learn more about the tutorials, but I hope you get the idea. You can extract the standard shapes automatically, or you can just press line and arcs and it will define the lines and arcs for you. There are a couple of options here that you can adjust. For example, when it needs to be perpendicular. In this case, it's less than 3 degrees, everything will become orthogonal. This is because you need to have a proper sketches rather than just the best fit on the scan date. I will just accept this for now. And if you remember, we need to make a cutout. So in this case, I will just delete what it's not needed because I need to create a solid of the revolved surface. As I said here, because we don't have scan data, it's your decision how to make the inner shape. You can measure it with a ruler if you want to and build up the inner profile. I created this slightly smaller with the control key. I can just intersect, extend this, make it bigger. And because I'm going to use the Boolean operation, I will just create this as a solid. We'll create a line here and we'll the line here. And I'm going to intersect with the control key these 2 points. This is good enough for me to create a solid. I will just show the trimmed surface, which is already a solid. We'll go to revolve, and here we have the operation that it automatically will create it as a cut from my existing shape, and press OK. Let me hide this, and we are ready with our reverse engineering object. You can add roundings and fillets if you want to, but this is what we achieved with our new tools, easily and simple. The other small features which we introduced, but it's really valuable for the processes to make your life much faster, is still in the 2D sketch. I can just go now to 2D sketch and we'll just extract this vertical shape. This is a complex curve here. I can just create this and accept. And what we have in our new development is when you extract primitives, together with extracting the lines and arcs and automatic sketching, we have a fit surface command. Actually, it's a fit curve, excuse me. How it works, you just say what is your target tolerance. In this case, is probably 0.5. And the minimum, the starting number of points is 8. And if I just brush over, it automatically will interpolate this for me. This is really a time saver that you can use while creating the sketches. And you can just brush over and quickly go back and intersect the shapes. This is, I forget here, but I hope you get the idea how this normally would work. I can just always just take these, either extend it, or you can just brush over and it will intersect. So this is really useful for the fast and efficient reverse engineering. The other feature I would like to speak is what people understand as Class A surfacing. What it is and why it's so important and where people are using it. This is the part of a Audi scan, and I'm going to use our fit surface command. As you remember, I introduced this in the extract primitives, but this segment option also is available for the fit surface, which may find really useful. And you can play with the radius and the sensitivity, and you can get the segmentation. In this case, I'm going to try to extract the fit surface on this. By default, it starts with the max degree, but I'll just remove this and use it in the old way. We have a UV and then the degree of the shape, which is 3 in this case. I can just apply these parameters and I can analyze the shape. It is within 1 millimeter, probably it's too tight so you can understand better, but if it's 0.5, it looks something like this. And maybe I will just make degree 6. It looks pretty good, and I'm going to export this as an IGES surface. And we'll bring it into Rhino. In Rhino area, what we can do is extract what is called the isolines. Let's quickly do this just by extract iso curves, and we'll create several of them. We'll change the direction to other way. It's actually something like this. What I'm going to do now is turn the analysis of the curves. Go to curve and graph on. What means Class A surfacing? What you see on the screen is the change of the curvature of these curves. Class A surfaces have a really smooth change of the curvature. As you can see here, you have some sharp edges. And although this might look smooth, it's not actually classified as a Class A surface. You have a sharp transition here, and so on and so on. So this is the shape that you get normally, even if it may look pretty much okay. Let's go back to QUICKSURFACE and do the same, another shape on the same data. Go to Fit Surface, play with the slider to extract the shape, and press the Fit Surface. I will go now and put again the 6x6 and press Apply. But in this case, what we have is it's a max degree. For you, maybe the shape looks pretty much the same, but technically this is a Class A surface because the continuity of the curvature is smooth. How to prove this? I'll just export this again as a IGES and on the same file, and we'll open it again, the same file in Rhino, and do the same things. This is shaded. We'll extract some isocurves. This one. We'll change the V direction so you can see more results. Here, press enter. We will now turn the analysis of the curvature graph on. And now you can see it's a big difference that the curvature actually changes flawlessly and there is no kinks, how it's understood in the Class A surface modeling. So this is the proof that with QUICKSURFACE 2025 you can now extract the Class A surfaces in an efficient way. The next feature I would like to speak about is the ability to edit the meshes in a more effective way, especially on the boundaries. If I just take this for automatic surfacing or for other purposes, this may not be good enough, so we introduce the boundary editing in a slightly better and efficient way. How this works is if I just pick a boundary, I can smooth the boundary. It interpolates these shapes. But if I pick this one and interpolate, first of all, it takes a long time, and secondly, it just rounds the edges, which may not be necessary, and this is something that we want. I'll just press Ctrl Z for now. What we introduce here is the ability to create anchor points. I can just pick this one and this one here, probably this. So I create the points where we don't want the boundaries to change. You can find other applications and play with your mesh editing. But if I have this, then I can easily just control which parts of the boundary should be smoothed or not. How it works, I can just double click on this and you see that the software smooths only the boundary between these anchor points. This might be quite efficient for many applications such as 3D printing, mesh improvement, and for the automatic surfacing. As you can see, this is what we achieved. Once you're happy, you can just press back, and this is the result you got. These were the major new features that we introduced in QUICKSURFACE 2025, and I hope that you find them really useful to improve your efficiency, simplicity, and the way you create reverse engineering from 3D scan data. I would like to thank for the data provided from Recreate 3D Dubai, RVS 3D Brazil, and Metrology UK. Thank you for watching.